Good morning, all. Welcome to this online course on analysis and design of RCC high-rise buildings. The reason to start this course, even though there are too many courses online available on the internet, the reason was that there was no satisfactory uh, performance from the people who have gone through all those courses and comprehensively the courses need to be conducted and the fundamentals have to be well rooted. And that is the reason I decided to take up this online course. And many people had advised also that they want a comprehensive online course on high-rise buildings, and collecting data from multiple courses was difficult for them. So there was a request, there was an interest to float this new and unique online course on RCC high-rise buildings. The basic, uh, what we say that difference in high-rise building to a low-rise building is the height factor. Now, as the height factor is increasing and the geometry and everything are connected with respect to it, the choice of the structural system becomes very critical as the forces will become higher due to the introduction of the lateral loads with respect to height. So bending moments, shear forces increase drastically, and the dynamic analysis becomes more critical. The behavior check is very important, and protection of the elements that may affect due to the lateral loads like the staircases or the non-structural walls. All these also become critical because in the event of the earthquake, the weakest link will fail first. So if a lateral force is going to the staircases, it will lead to the failure of the staircases, and that is the route by which the people can evacuate. So IS 16700 has specified a clause on that. So we'll go through each and every clause, the significance of each and every clause, why and how to understand the reasons. So if you don't understand the reasons why the code has been made and why those stipulations are there, you will not be able to justify your design, or as a structural engineer you should have a choice what you want to do. So there are many projects in which you need to dictate the terms that the design will have this type of arrangement only, otherwise it will create some weakness in the structure building structures. And the performance of the past structures in India have been moderate, and not all buildings have failed, but after the improvement of the IS 13920 in after the Bhuj earthquake, the performance of the buildings have become better, but still the understanding of structural engineers to implement them has not reached to that particular stage because disaster and its mitigation is in itself a detailed subject. And if we are just bounded by the cost of the project or the given scope by the architect, then it becomes very difficult for all to justify the role of a structural engineer. So when we talk about nation building, we should be very serious on that, and we should have a good understanding on how the building should behave or perform in operational condition, that is service conditions. What is the service life we are putting on the design as a structural engineer? It should serve that purpose also up to that particular life cycle, like 50 years. If a building has to give the service, it should be able to do that. So all those parameters should be considered, and now the new concept of sustainability is there. So how to integrate sustainability in your buildings? That is also some part we will see in this course. And another part is your performance. So performance and sustainability are two important parts that we will see in this course, which I don't think any other course is covering except IS Structi is covering this aspect in the latest online course that they have launched. So with respect to that introductory note, I will take you to the course brochure that is shared with you. But if you have not gone through that, I'll reshare the course brochure with you. So we should understand the modalities in which the course is going to be conducted. So the title of the course is Analysis and Design of RCC Buildings as per Indian Standards. And it is why Indian standards have been mentioned because specifically the inferences from the other codes have been taken in Indian standards, and many people are confused that can we use ACI code or ASC 07, and because Indian code does not have the clauses, and how to, and second part is how to justify our design by following the Indian norms. So some say that these norms are only theoretical and not practical. So that aspect also we'll see in our discussions. That's why specifically Indian standards have been kept. And why I have written manual plus software is that first we should do a manual analysis, and manual analysis will help us to gauge the nature of the problem and what is basically whatever the software is showing, whether it is correct or not. We will not be able to know until unless we have evaluated some problems by ourselves, like how much moment is coming, how much shear force is coming, what end restraint is provided, what effect will it have, and what are the methods to solve it, and how what are the methods to check the software results. Now I have designed a building, but I need to check some part of it manually. So how can I do that? So all these things will need the exposure to the manual analysis, and whatever has been in the textbooks, it is the same thing. So involve means reading the textbook and understanding the assumptions taken in the manual analysis is critical. And mechanical procedure versus understand the method and apply it. There is a difference between the two, and hence we should be sure that whatever we are doing in the software versus the manual part of it, both should match with each other. You will see that manual results, software results are not matching because you have not taken exact understanding of the manual procedure which needs to be implemented and compared with the software. Okay, so that is a clear understanding of which method to be used and what is uh, whatever the difference is happening uh, with the approximate methods and the software results. So if you are using the approximate methods, your results will not match. If you are using the matrix method, it will match up to a certain limit with the software. So we'll be going through the approximate methods in manual analysis, and we'll check what the software is showing. So this manual analysis we can do only for a limited height of the building, not for the full building. Like we can do a full manual analysis of a G+3 or G+7 building, and including the earthquake, like with shear walls, then uh, what we can say, the center of mass, center of rigidity, then stiffness consideration, modal analysis, and that is eigenvalue and Ritz value. Both will do the manual analysis. Like when we use the Ritz factor, what will be the change, and when we are going through the eigenvalue analysis, what is the change? Because eigenvalue solutions are with respect to the uh, natural behavior of the building. That is the what we say unforced vibration. Now, when we are going with the Ritz vector, only those modes which will get excited during the forced vibration, because the earthquake is a forced vibration. So, in the forced vibration condition, how many modes are going to be excited if we are doing analysis with respect to that? So, right now, many people are going with Ritz vector for analysis in ETABS. So we'll see a problem in which it has been done, and if we will see the results in two methods, eigenvalue and its vector, but both have a theoretical background. So we'll also go through theoretical background of the dynamic methods of seismic analysis and manual method for the this wind analysis also, like dynamic wind effect using the gust factor method, how it is done, or there is a desktop study, how desktop study is done for the simulation of the wind loads in FEM softwares. So we will not do a full simulation, but we will just understand that how it happens and in which cases we should go with the desktop study. So wind tunnel studies can be replaced with desktop studies, but there is a certain limit to that. All the parameters or results in the uh, this uh, wind tunnel testing cannot be simulated in the desktop study, but in many cases, when we did the desktop study, the forces were coming out to be less than the IS code method. So in that case, we take the IS code forces, gust factor method, and design the building with the higher loads. However, if you have what we say, uh, if you go through IS 16700, it is saying that if the forces are higher, then we have to go for the wind tunnel testing forces from that. If they are lower, then we have to take the IS code. But in many cases, the facade design engineers to optimize their uh, project cost, optimize the cost, they do the wind tunnel testing and they optimize the uh, this facade for that, not the main structure. So facade engineers use the simulation model to reduce the forces. If it is on the lower side, if they find that it will lead to lesser force, they use the desktop or the wind tunnel results and design the facade for that. So we'll also go through code that is used for facade design in these sessions. So manual method has approximate methods are very vital to understand gauge the problem, that how it is going to behave, how it is going to respond, how the member is having their bending moment, shear forces distributed across the height of the building, then what element is taking what force. So this manual method will help you understand that better. And the software can be, you can check the difference between the manual and the software method, how much difference is coming. So that also we will take, and for a small building height up to 7 story only we can do the manual method, and beyond that the target is in this course to go up to a 30-meter building along with the podium or the basement. So building with 30 floors with podium and basement, we should be able to understand, we should be able to solve it thoroughly and check the software results manually. So where the checklist or the what parameters to be checked in the software manually will be discussed in detail. So I'll just put this brochure in the WhatsApp group. You can also go through it in detail, but I will just highlight a few points. So the responsibility of giving the strength, stability, durability, resilience, and long-term performance lies with the structural engineering professions. But what happens is that when we are bounded by architect or we are bounded by the client and we are not able to speak the requirements, that is when the value of the structural engineer reduces. And if there is no budget for higher performance of the building or higher durability requirement, or you are designing building only and only to follow the code, because code is saying minimum this much is to be followed. So what your design principle happens is whatever it is there, we have to give the optimal and minimal only. So when your principle becomes optimal and minimal, you will not go or think beyond those boundaries, and your solution will not grow. It will be the same in all buildings that you will do throughout for a given height of the building. So what type of arrangement requires what suitable uh, implementation of the like parameters or arrangement or what value you can add to the project will be only in the hands of the architect, not in your hands. So this is where you should not get constrained if possible, and try to avoid taking a project that will not give you any uh, fruitful result at the end of the project, or let's say many projects will not give you a glory, but it will help you to survive in the market. But you should not compromise on the many things. You should compromise only on the small things that are possible. So you should have your own understanding that what I will allow to happen, what I will not allow to happen as a structural engineer. So that is very critical because your professional practice is not just yours, it is of the structural engineering domain at national level. So it is like uh, adding the contribution of each structural engineer across India will help to mitigate the current situation that we are facing as structural engineer. That the contribution level is low and the software is giving the result, and minimum is designed by the minimum is done by the structural engineer. So that should not be represented that way. And what are the opinions, what are the requirements should be stipulated by the or the governed in the design basis report by a structural engineer. So what structural engineer can regulate is design basis report. Once the design basis report is approved from the client or the architect, your design is going to be in that particular direction. So you have to ensure your design basis report does not have just the minimum things. It should have all the requirements that how you are going to design a building for your project. It will be code compliant. That is the one part. But design basis report should be inclusive of all the requirements that are required to design a building with strength, stability, durability, resilience. We will understand in more depth. Long-term performance. That is all in the hands of the structural engineer. No, nobody else can give or add anything except the structural engineer for this. Okay, so I hope I'm able to stress enough on what are the roles and responsibility of a structural engineer when it comes to the nation building or the creating an infrastructure for the country. So fundamentals in the building design will require a structural engineer to go in higher depths of mechanics and physics. So when we are talking on the mechanics part, that what is the mechanics in this? So one is the rigid body mechanics, and second is the deformable body mechanics. So rigid body are like everything is rigidly connected and none of the elements will bend, whatever are connected to it. Okay, so a body which is like a sphere is very rigid, so it is not going to bend from any place. So in that we use the rigid body mechanics. Whereas when we see a beam or a column, it is bending and its deformation is not equal at all points. Okay, so at the joints, we don't joints are considered to be rigid. That's why the degree between beam and column is 90 degree. That is what we assume. So once we are considering joint is to be rigid, the angle between the two elements are not changing. However, the beam and column independently are bending with respect to their local axis. So this deformable mechanics has slightly different requirements that we have seen in our undergraduate studies in the books of the mechanics, that deformable bodies or Ramamurukam is the best book in that. So you should have good understanding on the deformable body mechanics, what assumptions we are using in that particular means analysis or evaluation. Like in the elastic analysis, we are taking the assumptions that uh, members are plane before and after the bending. That is the first assumption we take in the flexure means assumptions in the flexure analysis. That in the elastic case, once the beam is bending, when it's come to its original position, it is not deformed after that. So before and after application of the load, before and after application of the load, the beam is in its original position. No deformation is there. So that is not a reality, but these are the assumptions we are taking for analysis or the design. And based on that, our stress blocks are generated, or the this formulas have got generated in the so all those assumptions should be clear, what assumptions we had taken and what is the practical requirement, and how the theory has got developed, in which cases theory has a limitation. That also should be clearly marked. And each and every course will not be able to go into all these depths, but why I'm telling you is you can uh, open the textbooks from the very basics and note down all the assumptions, all the theories, limit state method design, what is the requirement, and all those things should be handy with you. So it is not like if this part is not covered in the course, you should not know it. You should know all these things. So your day zero should start with understanding of the fundamentals, going back to it. What are material factors we are taking in design? Like for steel, we are using a material factor of 1.15. So we are reducing 1 divided by 1.15. So 0.87 of Fy, we are taking the capacity of the reinforcement in design. So we are reducing the capacity of the steel reinforcement by 15%. So 1.15 factor, material factor for steel, then 1.5 factor for the concrete. So 0.67 divided by 1.5 is 0.36 FCK. So how from FCK we have reached 0.67, and how from 0.67 we have reached to 0.36 FCK. So 0.36 FCK B into XU, D minus 0.42 of XU, how we have reached. So that also should be clear to you for simple cases. Because when you understand the stress strain diagram, when you understand the material, then only you will be able to go further in the design part. So all these aspects are of mechanics. Okay, so we are going into the mechanics and the physics. So physics comes into the deformation of the body, behavior analysis, that is I call the physics. So mechanics is related to the materials, type of assumptions, uh, how we are doing the testing of it and putting the stress strain parameters, stress strain block is there, how we analyze the element, how we calculate the shear force, bending moment, that is all part of mechanics. After applying the forces, how the body is moving or behaving, that is part of the physics. So mechanics and physics both should be clear, that when lateral load is applied, what element is going to behave in what manner, and how the load path is generated. So load path is first element on which the load is applied, from first element to the last element, how the force is distributed along the height of the building. That is from the slab to the beam, beam to column, column to foundation. If there is a shear wall, then the flow of forces from the floor to the shear wall, how it is happening, and if the joints uh, or the restraints are correct along with the shear wall or not. Because if your slab is not properly connected with shear wall, then it will not transfer the forces to the shear wall. So it will redistribute to the other elements. It will lead to failure. So all these things should be understood in detail, that what type of connections we are doing in RCC. Like many people are releasing the elements in RCC, like beam release for torsion, beam release for secondary beams are also released. Like if the secondary beam is of 600 depth, okay, then also it is released, understanding that the detailing is like we will not fully connect the reinforcement with the main beam. So secondary beam can be taken uh, as simply supported, and we will release at the ends where the this secondary beam is connected with main beam. However, it is a rigid connection by its very nature. If you are not providing a reinforcement, it does not have a tension capacity, so it will crack. Okay. So once it will crack, it will reduce the stiffness of that beam. However, your main beam is designed considering the secondary beam is there, so you are reducing the effective length of the main beam. So that will affect the design of the main beam. So that is very critical, that where what type of assumptions you are doing and what beams you are releasing, and just by detailing, if you are able to control the flow of forces, you need to justify that, which many people are not able to do in, and I have seen all buildings in which majority are beams are released. So with beam is connected to shear wall, then it is released, then secondary beam of higher depth connected to main beam of the same depth. Okay, so both have the same depth, secondary beam and the main beam, and there is a release between the beams. Just because the reinforcement is not detailed in that particular way. So that is reduces the stiffness of the full building. Okay. So what happens if you are not providing reinforcement to create a rigid connection? The secondary beam will crack. Okay. So overall rigidity or the integrity of the structure will get compromised, which you are not modeling in the software. In the software, you are only assuming moment is not transferred. However, whatever the stiffness reduction has happened, you are not considering at the joints. So integrity becomes very difficult to consider in such cases. So releases should be controlled, and without understanding the releases should not be provided. And the continuous load path should be ensured. So load path is very critical, and continuous load path should be there. Integrity is very important, and ACI code focuses more on the integrity, that elements should be connected properly with each other. So integrity part is critical for any building that you are undertaking. So mechanics, physics, and practical understanding of the problem. So all these are very critical for delivery of any project as a structural engineer. So I will be focusing on all these aspects in the course as we go ahead. Some introduction on BIS I have mentioned, in which year it was formed, and what is the role of BIS. So first thing is behavioral understanding, like the mannerism in which the each load asks the building to behave. That is very critical, in which the stiffness, constraints, releases, all these are very critical parameters to evaluate the behavior. So you are evaluating the behavior, but you are not using the right parameters to evaluate the behavior. Like a release may not be possible, but you have given the release. Now you are checking the behavior. It is showing okay to you, but in reality, the building may not be okay. So you should uh, do the behavioral checks with all parameters, with practical consideration, theoretical assumptions, and uh, more realistic approach should be there. Now, estimation of all type of loads we will cover in this course. Now, what are the methods of structural analysis? One is the approximate method and the software method. Both we will go through that. Now, what are the structural planning and principles of design? That is important. Like structural planning is uh, what is the structural system you are going to first, is the first decision you have to take, that what structural system I am providing, whether it is a shear wall system, whether it is a flat slab plus shear wall, whether it is a frame, moment resisting frame plus the shear wall, or just the moment resisting frame. So all these are very critical aspects in which you do the structural planning, because structural planning will be done once you decide the structural system. So which system is best for this particular building that you are handling, and after that you will plan the elements, where I will put the wall, where I will put the column, where I will put the flat slab or the perimeter beam. All these are very critical segment of it, and what principles of design to be followed, like code compliance and Second part is which elements to be considered for what purpose, like lateral load, uh, elements, gravity load elements, then perimeter elements. So all those elements have to be properly understood and integrated in your design. Specific to seismic design, what are the principles like collapse prevention or continued operation, like for hospitals, how to ensure that, how to design for that, what is the aspects of ductile detailing, and how to ensure all these aspects in for a building project. We will be going in detail as per the Indian standards. Now, whatever the design of the footing or the foundation is, that in detail in this course we are not going through that. But for the simple isolated footing, we can use the ETABS software. And other part is you can also do a pile design using the ETABS, but you need to know all the parameters of the soil. So geotech engineer is necessary for giving the stiffness properties, like the coefficient of friction is mu, and there is a parameter nu, uh, shear coefficient, coefficient of friction phi. All these parameters are needed to model the horizontal spring, and the vertical spring can be easily modeled. But when you are doing a pile with full analysis, your horizontal spring and vertical spring both are needed. So geotech engineer has to be onboarded or your discussed with them that what parameter I should put and how much depth is a fixed depth which will go inside the soil, and what will be the above height of the this pile which will act as a column. So that fixed depth which is below the ground will be should be modeled with the springs horizontal vertical, which is very detailed aspect, and geotech engineer approval is necessary in all these parameters. So you cannot, a structural engineer cannot directly do it. For vertical springs it is okay, but for horizontal springs you cannot just decide by yourself that what is to be done. Now, introduction to performance-based seismic design, because performance-based seismic design tells you that what are the important parameters you should consider. So, in the elastic design that you are uh, undergoing for a building, you should take care of the post-disaster effect also. That once the earthquake has happened, what will be the effect on the building, and based on that, the clauses of 13920 also have been updated. But your understanding in design of building will improve once you understand what is performance-based design and why we are focusing on the performance in regions that are in high seismicity. Okay. Then time history analysis, how to do it in the ETABS software. So we will be also going which methods are used by the software ETABS, like Newmark beta method or whatever the methods are there, how they are using it and solving the problem. We will also go through that in the theoretical as well as the software. So wind loads on buildings and dynamic wind effects using the spectrum method. We will go through that. Detailing of structures for execution drawings. What detailing standards should be maintained, what our drawing outcome should be. So all those things we will discuss in detail. And project workflow and BOQ basics, that what happens in current projects in which are going on in the market, that what method they are using for delivering the project, and how the BOQs are generated from the BIM models. So we will not go through the BIM tools, but we will have a just understanding that how it is done. So methodology should be clear, and whatever the tools are there, whether it is Tekla or whether it is a Revit, you should be able to work with that, and some broad level understanding should be developed. So why ETAP software we are using in this course, I have mentioned it, so you can go through that. And it was developed, the ETAP course was developed in 1975 in Berkeley, USA, and it is one of the best tools in designing for earthquake resistant design of the RCC buildings. As compared to other software, this software has more detailed approach and better consideration of all parameters that are needed. And also the nonlinear methods of analysis are also detailed or the elaboratory way they have covered in their codes, and that is the reason we are choosing ETABS as a global tool across the globe that it is helping the structural engineers in designing the RCC buildings. However, as a structural engineer, this uh, has backfired also, that if software is doing everything, then what a structural engineer is doing. So that can only be resolved once you undergo or make yourself braced for delivering the building designs independently and use software just a tool, not as a resource. If you make software as a resource, what happens that your part is being done by the software. However, the uh, procedure should be that it should be used as a calculator, not as a resource. That if we feed something, it will give us the output. We don't know what output has come, but software has given. That's why it is going to be okay. So that is not true, and you should know how to check the software, how to improve the results, and what to do with the software is very critical. So what everything you are doing and software is just giving you an outcome. So that is just a outcome screen in front of you, and which has reduced your time and effort. That is the only part of it. However, the control mechanism should be only with the this structural engineer, not with the software developer. Yeah, I welcome Kilesh also. There is Mr. Kasim. So hope you are getting the points what we are going to cover in the course and how it has been outlined and how it is distinct and what is the expectation uh, or the way forward from your side and from my side also. So after this course, you should be independently able to do a full project considering uh, all the right parameters and let's say it will not be a magic after the course, but your fundamentals should not be compromised. So your fundamentals should be very strong. So this what is the content we are going to study is all Indian standards step by step. That is IS 875 part 1, that is for dead loads. Part 2 is for live load. Then part 3 is wind load. 1893 is earthquake resistant design of buildings. Part 1. 13920 ductile detailing of the buildings. 16700 tall building code. Then 456 2000 we will also discuss some of the draft requirements at the end of the course, not right now. Then SP16, how it is helping to design. So interaction curve, whatever is there in the SP16, you should also be able to uh, make for it. Like what ETABS is giving you interaction curve versus what uh, SP16 is giving you the interaction curve. Are they same or they are not the same? How will you check? Because if your interaction curve is not the same, your moment capacity and the actual load capacity is not the same. It will be both be different in the software and in the SP16. So how you are actually superseding or improving the version of the software. For that, you should be very clear that how the things have grown up in the Indian standard and what is the current procedure being used by the software and which is better. Would we use the SP16 and your software is also using SP16, then it is okay. If there is some change in the interaction curve, then you should know that what change has happened and should I go with that or not. So is there anyone who has checked the uh, SP16 interaction curve for the columns, PM interaction curve, and compared it with the software? So anybody has checked the PMM interaction curve of software versus the SP16 code?
No, sir.
So that is very important because uh, how you are designing a beam or a column uh, and manually versus what the software is showing, that can never meet if you have not checked. So you should always have a check that if a biaxial design of a column that you are doing with IS code versus biaxial design or uniaxial design by the software is matching or not matching, and what PU and MU has been taken for design part. Like what percentage of steel is coming. Okay, the software will get some PT, and you have also taken some PT value. So is it nearby each other or not? So that is the validation part, software validation. So manually you need to, we will be checking, and that is one important part many courses don't cover. And I have personal this interest that as a structural engineer we should not uh, just accept all things given to us. We should question and we should evaluate, validate, and then we should propose for it. Otherwise, whatever we propose as a solution will be always incomplete. So I request all structural engineers or practicing engineers to take a higher stand and check the practice, just the what we say, pressure of the time, pressure of the client. Temporary, it is okay, but you should grow by the time, and there should be delta improvement in your practice with growth of the knowledge within you. Okay, so you cannot just say that we don't get time to evaluate the parameters, or it is a more on the research based things. It is not a research based thing. You should know all these things, and that should be part of your practice rather than just saying that we are like practicing and learning. But your practice, if it is not up to the mark, you will not grow correctly in that particular direction. Okay. So just what I told, that depending on the software, for some parts it is okay. However, for design part, you cannot depend on any software. Design is yours. Analysis, you have to depend on the software because it is more on the matrix analysis in which three-dimensional elements are considered and 3D analysis uh, means carried out by the software. So in that part, you cannot validate much until unless you have yourself has a 3D analysis routine written with you. But except that, the design part, you should be in control of the building. You should know what is happening in the software. Just give me 10 seconds. So going ahead with that particular, I hope I'm audible to all. So going
Yeah.
ahead with that
Hi, sir. I'm
particular,
Achilles. I
yeah,
want
hi.
to add one point, sir. Actually, sir, in SP16, sir, we have some limitation like, sir, like four-phase equal distribution and two-phase equal distribution, sir. So our real cases, sir, mostly we cannot compare it with the SP16, sir.
Yeah, so it is always a question that four-side distribution I am doing, and
Yes.
SP16 is mostly two-side distribution. Then
Yes,
how
sir.
should I consider the capacity of the column?
Yes, sir. Yes, sir.
So that is the one part that we are actually depending more on the software, that now this is the practical case, but we don't know how to evaluate it. So what software is
Yes,
giving,
sir.
we are going ahead with the capacity of that column, and what assumptions we had taken, or why the SP16 is not having four-side distribution. So nobody is also questioning that. So nobody is asking the BIS committee to improve the SP16 code and include four-side distribution. How software is able to do that, and we are not able to do that.
Yes, sir.
So in that particular thing, that when you develop a interaction curve by yourself, you will come to know better than in which case the software is taking four-side distribution. Like if I take only one space and I apply the load in only one direction, will it take four-side distribution or will it take two-side distribution? So how is software considering and how the FP16 has considered it? So we'll also go through that in this course, that how that's why I told that mostly the design part you have to regulate, because software is quite different from what we are considering in the designs. As per the code of practice or the routine, these textbooks also don't have all those parameters mentioned. Like four-side distribution, then what will happen? Two-side distribution, what will happen? So it is mostly based on the stress and strain analysis, that whenever the load is applied on column in one particular direction, like MU1 and PU is there. So in one direction, force is applied. So there are two phases, one phase in compression, other phase is in tension. And the reinforcement, each reinforcement as a layer will have the strain developed in that. So based on that stress strain analysis, you will come to know whether uh, two-phase reinforcement is able to satisfy the results or not. But when we go to a 3D modeling and 3D software, there is a twist also that the column has to take. So what I think is, when we consider the actual forces on the column and then give a final product, it should match with the software, because all forces in both direction, MU1, MU2, then the twist and the axial force, if all are considered properly, I think you should the strain analysis should give us the result, and that is the reason we should know that how these formulas of the SP16 have developed. So only a few textbooks have a very good explanation on that. I think BC Punamia and AK Jain, they have covered mostly in detail all these parts. However, I will be inviting Professor H.J. Shah sir uh, for the beam and column design. Okay. So he will cover the aspects of the beam and column design, and in those sessions we can go for the PMM interaction curve, how it is developed and how we can also understand it better. So thank you for raising that point. So that will be part of it. So the first session, that is lecture one. Today we are on lecture zero. So I'm just clearing on the modalities, and I have uploaded a few sessions on my website, and you can also go through that, or it is also available on my YouTube channel. So up till next week, you should also go through all those videos that are available. And the session is on the behavior analysis of a building. So why we are going on the theory part? So initial sessions I have kept mostly on the theory part. So whatever understanding we should have, we should get up to this much part of the lectures, up to 9 or 10 lectures. We should be clear with the theories, and after that, uh, design is going to be covered. Then we are going introduction to ETABS on the 17th lecture. However, what I feel is that you should start with ETABS understanding. There are various channels on YouTube on which the or the ETABS themselves, they have a channel. You should go through that first, because those elaborate details are covered, which I cannot just I don't want to just redo it in my sessions. But when we are modeling, I will go through each and every step. I will show that what are the tools, what are the uh, options. So full building, I will model in front of you. We will apply the loads. We will apply the do the analysis. Then we will do the design and compare the results together. Okay. So that part I will cover, but you should also go through the official channels of ETABS. Okay, so that is important. That you should have gone through their official information that they have shared. Okay. So behavior analysis more on the aspects of time period and systems, all those things I will cover in detail. Mostly we will use the seismic design guideline shared by Dr. CVR Murthy to GSDMA. Okay, so we'll go through that in the course. So for 1.5 hours as the first lecture. So it will be totally from Dr. CVR Murthy's this guideline for building behavior analysis. So that is the next session. We will be going through that. Then after that, manual analysis of three-story building as per the approximate method. So what are the approximate methods? Uh, Let me take a bit onto that. So let's say this is our simple building plan in which because it is a three-story building of let's say 5 meters center to center of the columns is there. Same way, these whole grids are connected with respect to each other. It is the most simple building that you will see in your textbooks also. Now, this when we are doing the gravity load analysis, what are the methods we use to solve this particular, let's say this is a G+3 building. So what is the gravity load analysis? What are the methods that we use? So anybody can respond on that. What are the methods we use for the gravity load analysis? So there is a column area method. Okay. So in the column area method, you are considering how much portion of the load this column has to take in its surrounding. So half on each side you will consider and you will analyze the column for all the loads that are coming here in the gravity. So what is the gravity loads we are taking? One is the dead load of the slab. Like I will say self weight. So it is a self weight of the slab and the beams. Okay. So at all floors, self weight at all floors you will consider. Second part will be your super dead load. Super dead load is your floor finish. And whatever additionally, there will be a live load. Now, in some cases, there will be a separate furniture load or whatever you are considering that you are generally considered as a factor 1.5. That is self weight also 1.5 we are considering as a load factor. So all those loads will get added into that. So mostly self weight, floor finish, and live load you will consider, and the column will be designed, means analyzed for the load that is coming from top story to bottom story. So this will be your column, and this will be the top story, that is the roof. That roof, there will be a brick bat cover, That is one form, or there will be some waterproofing, oblique waterproofing loads. Now there is a requirement of solar panels in Mumbai that you should have some uh, capacity on the roof of each building. Then you will take additionally the solar panels, which will be at some height from the roof, so you can walk. However, the solar panels will also be there. So if live load can be compensated, so if solar panel is coming on some portion and people are not able to walk in that portion, then solar panel load not to be taken. It will be taken directly through live load. If it is a separate uh, arrangement, so live load will also be there, solar load will also be there, then it will be added accordingly. So that way 1.8 meter by, let's say, 2 meter or zero point 0.5 meter, one panel is there, so there is a weight generally you provide. So many sizes of the solar panels are there. Based on that, you will get the loading from the internet and you can use it. So all these loads will come. This is on the roof. This will be your ground floor. This will be first floor. This will be second floor, and this will be the third, which is the roof. Okay. So this way, whatever the load is coming from the roof to your column, so you will get actual load. You will get some moment, and this again, this load will be transferred to this particular level. So if I say it as P1, this will be your P2. Again, it will be P3, and finally on the footing that you are going to make below ground. Okay. So finally it will be P4. So all level the force will get transferred and moment will get generated for the footing up to the footing level. So your column at each level will have gravity load for which you will design for that. You will get a reinforcement. Your PMM curve will be useful for that. And up to the footing level, we have to use this method to estimate the load, which is very simple and easy to use, including the partition wall. Okay, this load partition wall loads also to be added. So all these loads, when you consider in gravity direction, you will be able to estimate or the design estimate the size of the column and design the column for the gravity loads only. So that would be the case one. What is the other method we use? How to design the beams? So column design, we can do it using column area method. How we can design the beams? What is the approximate method for that in gravity case? Now, the column also can be designed with beam reaction method, which is actually a better method because in this beam reaction method, whatever the beam is coming onto the column, okay, so whatever this beam will give reaction. So this is R1 and this is R2. Okay. For that, you will design at each floor these two uh, R1, R2. Then these two beams are also there. These two beams are also there. So if you want to design this particular column, okay, so you need reaction from all sides. So if I don't give it as R1, I will now give it as let's say this will be R1, this will be R2, this will be R3, and this will be R4. So reaction from all four beams coming onto the column. Okay. So for that you will require a beam. You will require whatever the self weight is coming. So whatever loads we have written, all will come here. And based on the end restraint condition, whether it is pinned or whether it is fixed, okay, how you are going to do that load transfer. because it is a gravity load case and all those parameters have already been designed. So this beam will have higher bending moment if it is a pin support. If it is a fixed support, it will have a lesser bending moment. So it will be WL square by 24 if it is a fixed connection. It is WL square by 8 if it is a pin connection. So there is a lot of difference between the bending moment. So what is the beam end condition and how to design it is critical part. So this is a beam reaction method. Whatever the reaction you are getting, you will transfer it to the columns. So you get the reaction, you get the loading on beam, you can get the bending moment on beam, shear force on the beam. You can design the beam with this method and analyze and design the beam using this method and also transfer the force to the column and design the column using this beam reaction method. So in the NPTEL courses, this has been covered in detail and also in books of Dr. H. Shah, it is covered. So volume 1, volume 2. Uh, Previous also it was there. In new also it is there, and NPTEL course also it is available. So all these methods are very important to analyze in gravity load cases only. So now when we are going to the next stage, that is the lateral loads. So for lateral loads, one is the portal method. So in the portal method, what we are doing for the same building that we saw, first, second, and third. I think there were more columns. Okay, so you can just add it like this. So if this is the given frame and lateral load is applied something like this, in this is the earthquake load in the parabolic manner it is applied. So this will be P1, P2, then P3, and this is all of fixed support that we have considered at footing level. However, this I have shown up to the ground. Basically, this column will go in more depth wherever it is fixed connection with respect to the footing top. So this is top of footing. So whenever your column is there, always we have to analyze up to the top of the footing. Okay, so all forces up to this level have to be considered. Okay, so in lateral load also, whatever the forces have been applied like this, all values up to top of footing has to be estimated. One is the portal method in which we assume that the hinges are in the center. So zero moment, not hinges, the zero moment is in the center of the column and the beam. That's why our bending moment diagram is something like this. Always center and symmetric on both sides. So if you see in the software, it is never the case. So you should know how to draw this particular diagram also as behavior analysis. So all these things play a role in design. So you should know what method of analysis with given assumptions are there. So there are a few assumptions in the portal method that also we'll go through that. So when the hinges are in the center, your bending moment is different. So if I give you a simple portal frame in NPTEL course, it has been mentioned. So they have given a comparison between the two portal frames in which one is fixed and one is pinned. I'll ask you, this is L, this is H, this is length and height. Okay, this is A and B, A and B. So what will be the reaction? Horizontal reaction? What will be the vertical reaction? What will be the moment? In this case, what will be horizontal reaction, vertical reaction, and moment in this case? So can anybody tell what will be the horizontal reaction at A in both cases?
Like horizontal is like P by 2 and P by 2 in both cases.
Okay, so this is P by 2 here, and same
Yes.
will be here, P by 2.
Yes.
Okay, and what will be the vertical reaction? So here I can write moment is 0 because it is a pin support. So
Mm.
moment cannot be there. So what is the vertical reaction in both cases?
The moment will be like a P into H moment.
Okay.
And we don't have any gravity load here. So I don't think so we need a reaction.
Mm-hmm. Okay. So any other person want to respond? What will be the vertical reaction? So basically, we should know these things, and that is the reason we should involve. Means we should uh, you know search for answers as this NPTEL course, whatever they have covered quite elaborately in many of the methods of analysis. And if you go through all these methods of NPTEL, they have very particularly solved the problem for the structural engineers. Okay, so now what is happening that uh, first we will draw the bending moment diagram for these simple two cases when it is a fixed and pinned. So it will be something like this. At h by 2, you have the zero moment. Okay. And in L by 2, also there is a zero moment in the beam. And this is the lateral load that was applied. Now I divide this into the free body diagram. I hope you will be able to understand it in a better way. So when the force was applied as P, there will be a reaction like this in the your beams. Okay. So this P load, whole P load will be applied in the beam or not. So axial force will be P or will be something else. How much will be the axial load?
P only.
P only, right? So this will also be P, this will also be P. So one is the axial force diagram in the beam that it is P. Okay. Now another part is that whatever the reaction of the beam is like this, right, to the given force. So this force in the opposite direction will act on the column, right? So now but in this particular assumption that we had, this is a fixed base. So there will be a change in the bending moment direction because it will have a let's say double curvature. So this double curvature is happening at h by 2 height. Okay. So this P force multiplied by h by 2 will give you a bending moment P into h by 2, right? Then again, this will act in, now the force is acting in this direction. The reaction at the base will be like P, and whatever the bending moment was there, which was negative, or so this moment is negative or this moment is positive. How do you decide whether the moment is positive or negative? So which side should I take positive bending moment and which side should I take as negative bending moment?
Sir, we have to choose one side. Like for tension, we are taking it at a negative side for tension.
Negative, positive will be a different case because so if I take this column and I rotate it, okay, something like this. So there is a force P acting here, there is a force P acting here, and that there is a some center line we can draw. So what type of moment is generated here is clockwise, right? And what type of moment is generated here is also clockwise, right? So on right side, the clockwise moment is considered to be positive, or on left side, the so where you want to consider positive is negative is up to you. But what I say is, if I give it as a negative sign, this will be the positive sign to be considered, and this will again give a moment P into H by 2 to me. Your reaction, horizontal reaction, and the moment is generated. Now, this moment has to be opposite to what has been generated above. So, if this was clockwise, this will be anti-clockwise. Okay, so you can say this is negative and this is positive that way also. Okay, so this way, positive, negative bending moment diagram, you should check where it is generated in what manner. So, P into H by 2 moment I have got for this. Now, now the whatever what is left is the vertical reaction. Now, how will I get the vertical reaction in this? So, up to this point, we have reached. Same will happen for this column. So now how will I get a vertical reaction in this particular element? Whether it will be like this or whether it will be like this, what will be the answer for this? So I have drawn it in the downward direction you see here. And this one in the upward direction, right? So this we will get. Now we saw individually for the beam and column. Now as a global system, full portal frame, we need to check also. So globally, what the bending moment is happening is P into capital H. That is for the total portal frame. It is acting something like this, P into H. Now there are two columns. So two columns will are of same I value. So this is I1, this is also I1. Okay, if there is a I difference is there, then the distribution will be different, and you will have to use moment distribution method to solve this problem. So right now in portal method, what we are doing, the 0 point is in the center. Moment of inertia of all columns are the same in the particular story, and that why we are able to use the portal method of analysis. So when this total moment P into H is there, here also should be opposite moment. Okay, so opposite moment has been drawn here. So this is P into H is clockwise, this is anti-clockwise, and that is already seen. However, that is for the local, not global. So this moment will also generate a tension force. So moment reaction is there. Now the whatever the tension force is generated, that also has to be considered. So now P into H. Okay. Now in this there also should be P into H in return, right? So P into H, and it will be divided by 2. So your answer would be P into H by 4. So this P, again the reaction is P here, and once we will see this particular element, it will be something like this. So all P will be like P into H by 2 here, and P into H by 4 is the bending moment. So let me redraw it. So I hope I'm able to make you understand that what are the assumptions and what how to solve simple problems should be clear for any of the given cases. You should not miss out on the simple problems. So now if I draw a column and if I give a load P and also I distribute this column in two heights, separate heights, then it will be more clear. So P into H by 2, you got a bending moment. Okay. And opposite reaction P. Now this will act as opposite reaction P here, and again it will be P here. So what moment you had got P and it was P into H by 2. Two values you got. Okay. And this is the again P and then it is P into H by 2. And total moment that was happening was P into H total and it was divided by L. L is the lever arm. So P into H by L is the moment. Then again P into H by L is the moment. So this lever arm is acting. So whatever the tension force is generated, when you multiply by the length, it will become P into H. And this is clockwise. This is generating anti-clockwise reactions. So your bottom moment will be P into H by 4. So H by 2 divided by 2. Okay. So that way it is P into H by 4 is the bottom moment and P into H by L is the vertical reaction and horizontal reaction is. So this way you have to take the vertical reaction or this horizontal reaction and the moment M. So this is your V and this is the F. Now you when you see this particular pin support, everything remains the same. Only thing is P into H by L is the moment which will not change. Global moment it is there, so it will not change. Again, it will be P by 2 and P by 2 only. Only thing is the vertical reaction will be P into H by 2. This is the only change that will happen in the this particular case. Okay. However, we don't have reaction. The moment will not generate. Okay, in this particular case because it will be zero. You are not generating a two-side. What we say. This column will not be divided. It will be total H. Your P is applied and total P is applied here and your moment is P into H in this particular arrangement. So there is no center point where the change in bending moment will take place. So all these things you need to consider. We will also see it once we are going in the steps ahead. I'm just trying to explain you the modality we are going to conduct the course. Okay. So the same this portal method we will apply to a three-story building. We will solve it with the given assumptions. Second is you have moment distribution method in which you can solve for the sway analysis. In the sway analysis, you consider the lateral loads and that way you solve the problem and find the bending moment and shear forces for the given frames. So if I1 and I2 are not same, you will use the sway analysis method of MDM, moment distribution method. So that is for the lateral loads, gravity loads. What are the methods that are on the approximate? Again, there is another approximate methods in which the shear wall buildings are considered. So how to solve for shear wall buildings? Like we consider it to be a rigid element, rigid link for coupling beams. So when the software was not advanced, how the problems were solved for a coupled shear wall. Okay. These are two shear walls, and these are the coupling beams connected to it. So this much part was considered as to be rigid, and that way it was analyzed. So we'll also see that method. So there is a textbook on the approximate method of frame analysis for seismic analysis. So that will also, we will go through that. Okay. So these rigid links will help it to analyze it in approximate method. Now another method was to consider it as a column. The shear wall was considered to be as a column, and it was analyzed in that particular fashion. So all these approximate methods for shear wall building also will try to cover. We may not able to go in full depth. However, I will request you to read the textbook before you attend the class, so it will be easier for you to grasp that what we are going through. Uh, or you can also refer it later, and you can ask your queries. But in the session, if you ask your queries, I will be able to better respond, and you will get better link for that. So how much you understand, it is not an easy book to understand, but so it will take some time for you to understand that textbook particularly. So Scarlett Johansson, this one by one book is there. I'll share with you uh, that book in the WhatsApp group. So I hope you are getting that what is the intent of this course, and what are the details that need to be considered while analysis and while design for RCC high-rise buildings, and how we are going to cover it. So that was on the approximate methods. That is currently the time given is only 1.5 hours. The reason is that we have a 1 week for it to prepare. So in the there is a 1 week to prepare for this session one. So we cannot be like 1 week we are not doing anything. We are just attending the session on the Sundays and trying to go through complete the course like this. So these hours are not representing uh, your efforts. This is my efforts that has been mentioned as 1.5 hours. Your effort hours are 2 months or 2 to 3 months, wherever whatever the course will take us. Okay. So there are 4 Sundays per month. So there will be 8 Sundays, then 2 months, then let's say 4 3 are 12. So it will last about 3 to 3.5 months at least. Okay. So this 3 to 3.5 months, your efforts are totally each day that you have to put in. The hours shown are only of the live sessions, and full textbook cannot be covered in a live session, and nobody can cover it. So whatever the courses are there, they just give you the half information, which you cannot process it later. What my idea is, why I have keep the sessions weekly, because I have to give you time to read and go through the details and brace yourself for the next discussion. Otherwise, what will happen that I'll keep on explaining everything. You will be, and it is an online class. You will not get everything in detail, whatever I am going through on the screen. So you have to be also thorough, and you have to be, self-regulate yourself. And because it is a course that you are wanting to develop your skill into it. So your efforts are on the higher side. I will be guiding you or mentoring you and solving your queries, solving the problems to the best extent possible within the constraint or limit of the 3 months. So 3 months offline and online, we are trying to solve a particular problem for high-rise RCC buildings to the whatever depth you are comfortable to solve. Okay, you are wanting to do in non-linear analysis, you are wanting to do in linear analysis, manual methods, or let's say IS code standards. So your efforts are has to be on the higher side, because we have also gone through all these details in my last 15-16 years. And based on that, what I can say is you have to utilize every week for yourself. Okay. So live sessions, like I told that whatever the resources that you need to evaluate. So I'll put it in the WhatsApp group today. All these things you should read. You should come something prepared. I don't blame you if you are not able to prepare it because of your timelines. If you are working professional or whatever the commitments you have throughout the week, but you should give yourself the time to reach the requirements of delivering a high-rise building. That is the intent. Okay, I'll upload the NPTEL those sessions in the WhatsApp group today based on our discussion. So you need to have at least one glance so that the next week is successful. Okay. Now, after that, we will go through the estimation of the center of mass, center of rigidity, CM and CR. Then, so if we look into it, CM and CR. Now, this is the center of mass, and let's say this is center of rigidity. Okay. Now, there is a shear wall system or there is a column system, beam column system. The CM and CR plays a role because this will give eccentricity. So in ETABS software, there are two options to consider it. The option number one is that you consider the eccentricity and provide in the table. By formula ESI is equals to, sorry, EDI is equals to ESI minus 0.5 of PI, 1.5 ESI plus 0.5 of BI, something like this. The formula is there. Okay. So this 1.5 is the dynamic amplification factor. And this happens because from the ground, whatever the earthquake is happening, it is reaching up to the top of the building. Okay, up to the base where the earthquake has happened. Okay, from this below the ground, it is going up to the building. So dynamic amplification of 1.5 we are applying, and B is the width. So this we estimate as per IS 1893. Okay. And we have to put it in the case of the response spectrum methods. Okay. And also in the if you are doing in this method, you don't have to apply in the static load. So either you do this, or if you are not using response spectrum method, then you can use this. Otherwise, you give eccentricity in only one of the cases, it is okay to do that. However, the response spectrum loads have to be matched with the earthquake loads. So this eccentricity is there. So one way is to put in this eccentricity. Second is you are shifting the center of mass to center of rigidity. So if you tick that option, then it will shift center of mass to center of rigidity. And that way, your CM and CR will coincide. There will be not no eccentricity. However, whatever the shear force or bending moment is going to happen. So what was happening? Lateral force was acting here. You are now providing here. So this was your force, and this was the bending moment you are applying. So force into eccentricity, that moment you applied, and shear force you applied on the center of mass. Now in the second case, you are shifting everything here, so the force will be applied at this particular point, and moment will be automatically captured by the software also. So two methods you can do the uh, evaluate the stiffness center and the mass center. Okay. So that we will evaluate manually as well as on the software. So this is the accidental eccentricity. What are the impacts on the structure? So how to estimate CMCR? After that, when we apply the loads, what is the impact on the structure? So 3 hours we have dedicated for that online session. So there is P delta analysis, fundamentals of P delta analysis, and full calculation will be shared. And also, so you have to now do the P delta analysis calculation by yourself and submit during the week your queries. Software result, whatever it is there, we have to manually estimate and share. So in the session, I will discuss the manual method to share the in which it has been. You need to refer and you need to solve manually for P delta. Oscillations in structures and structural dynamic applications in building, linear dynamic analysis. So 3 hours for the would be important for the dynamic of the buildings. Only. So that we will be discussing and will become a field of lesson. So we will discuss what the oscillations. So theory part, we are complete. Of oscillations should be
So your voice is not clear.
okay. Am I audible now?
Yes, sir, now audio.
Yeah. Okay. So on the what irregularities, which is the vertical and plan irregularity and torsional irregularity, the theory we will take for 2 sessions. And for torsional irregularity, I have uploaded a video on my YouTube channel or the website. So I will be uploading all the videos on my website. So all session videos you can go through on my website, and I'll give access to you for that website. Okay. So only limited people know that website. So you will be aware that from where to read the sessions. Okay. So this is already uploaded on my website. So you can go through that. Uh, and after that, this fundamental understanding on one is the elements used for the model. What are the irregularities? What are the methods of analysis? What is P delta analysis? What is accidental eccentricity? How to calculate center of mass rigidity? Then effect of manual methods, behavioral system, behavior of the buildings. We will focus on the basics of the design, manual design. Okay. So slab, beam, column, shear wall. Okay. So all these are the designs we are going to conduct sessions on that. Okay. So this is how we will reach to that particular stage. Then structural planning of building and gravity columns, how to include gravity columns, the clauses for that. So understanding up to this much point, we will cover everything to be implemented henceforth. And from session number 16, all others would be software application based. Okay. Up to let's say 20th, all will be application based in the ETABS software, how we are getting and results for that. And building design in ETABS, verification of the results of the ETABS. That will be part. Serviceability checks, how to conduct. Backstay effect for the dynamic wind load because it's a FEM simulation, so we cannot do it in this course. Uh, but we will understand that when to do desktop study, when to do wind tunnel study, and when to you go for the gust effects of the building. So comparative of that. So this is how the 36 hours of mine is decided. This is my 36 hours to you in live session. What your efforts are going to be there are round about 3 months that you have to be dedicated for this particular course. I don't say that it is very rigid, but it is something somewhat rigid from my side because if you yourself are not solving the problem, you will not be able to justify at the end of the course whatever I am. My intention is through this course. So I don't want to be a course in which just you have gone through and you like the methods and all those teaching, but you're not implemented them. Okay, so I have not given certificates to people who are not justified the course at the end. So I hope the modality is clear. So first session was to understand the modality, how we are going to go ahead and what is the expectation from your side, from me. And now you can also uh, means discuss your part that what is your expectation from this course and whatever I have mentioned, you want to cover anything beyond that, or what are the specific things you want me to cover. If I know in advance, I can include in my sessions. Yeah, so floor is now open for discussion. Hello.
Hi, sir. Sir,
Yeah.
for the course content, sir, I'm satisfied with what are you providing, and that backstory effect, I feel like you should like give more emphasis on that.
Yeah, it is actually what I will do. I will upload a video in advance for you. Okay. And that you can go through, which I have currently taken with the one of the institutes. So that will help you to get the basics of it. And in the session, I will just cover the application side of it.
Okay, sir.
Yeah. So all the basics, fundamentals are covered in that particular session.
Yes, sir.
So Kasim, Nagi Reddy, any inputs or your means what you anything you want to say regarding the modality we have just discussed for this online course?
No, sir, no. Yeah, I'm actually satisfied with what you're providing based on the lecture plan what you're giving.
So these are all my efforts that I have shown you. Okay, your
Yeah.
side, it is limitless. How much you will get involved, you will be on the better side at the end of the course.
Yes, sir.
So intention is to have a basically more informed building design. Your capability should increase, skill level should increase, and whatever the designs come out as a result of it should be beneficial to the not just to you, also to the domain as well as society.
Yes, sir. Thanks.
Okay, so I'll show you how we are going to add you in the group. Okay, so I'm using MS Teams as the software, I mean, tool to have this online courses. So as you can see my screen, these are the previous course list that I have conducted till now. So PhD people also knowledge series they have come across. So I have made a separate that way. Now there is a steel design also, but I'm not sure that many people will be able to uh, justify the design because it is not just the structure part. There are many parts in PEB that you should know before going into that particular domain. So this can be the first step, but the design involves a lot many parameters to provide. So maybe a different course I will launch in a later stage. Now there is a course on PVD, but now IIT Roorkee also has a course on that. Okay. So this team analysis and design, as you are added to this particular high-rise building uh, group. So all details you will get in this particular group only. So whenever the session will end, you will get a notification here if I have added you in this particular group. So how to add you in this group is I need your particular this login ID so I can add a member into this. So right now no members are there because I don't have the MS Teams login ID. So I need your MS Teams email in which you have logged in the MS Teams. So I can add you here. So can anybody give their MS Teams email ID to me right now for a sample?
Yes, sir, can I?
Yeah,
So, SRI, Srinivasu,
SRI.
SRI, NI,
NI.
NI, sir, VASU 89780,
Srinivasu then
89, number, sir, 89780.
780.
Yes, @gmail.com.
So once I add you in this group, you can see it in your MS Teams that uh, so right now it will add in some time. Okay, so member will get added and you will be able to see it in your MS Teams this Teams group. Okay, so better you download it. Means use this MS Teams on the desktop and have this particular Teams in which you are particularly added in here. So once you are added here, what is the benefit is that you will be able to see the post. You will be able to see whatever the meeting is going on or whatever the meeting is arranged for the next session. So I will create a calendar for it. So you will be notified whenever the session has started. Now, again, you can ask your queries, start a post, and you can keep your query here. So mostly depending on WhatsApp, I better use it MS Teams, everything. If you are comfortable with MS Teams, you can put your queries here because it will remain for you for a long time till you are in this particular group. So you can refer it any day or any time in this uh, arrangement. You can ask your queries. I can upload the files here. Okay. The recordings will also be uploaded here. So in this particular folder, today's recording will automatically will come and you can go through that particular recording from this recordings tab. Okay. And I will also upload the various means books or different things which I cannot do it on the WhatsApp. Some things I can upload here only. So notes, everything I can upload here. You can have the recording here. You can have the discussion here. Everything is possible on MS Teams once I add you in this. particular group. So I will be needing your Teams login ID to add you in this group. You will be able to see it in your MS Teams, and all the recordings will come in this only. Okay. So I hope I am clear that how to use this group. Now, other part is related to the website. So I have shared the website uh, on LinkedIn, and let me see. So this is the website in which this link is there. Okay, that I will just put it here in the WhatsApp group. So this you can refer, and in this, when you go in the recordings, RCC buildings, there are a few recordings I have kept. This is the torsional irregularity. Now this is shear wall design. This is theory and application of shells, the theory part of it. And 3 videos I have uploaded yet. Okay, so you can go through these videos, and the IS codes I will all upload in the MS Teams. Okay, so IS code, ACI code, or ASC7 code, then your what we say, some of the instructions or all upload things, I can do it in the MS Teams directly. So you can refer it. The models can also be on the MS Teams, so you can use it. So everything can happen on MS Teams rather than only WhatsApp group. WhatsApp group we can use for coordination purpose, random coordination we can do, or some error on team happens to you, then you can notify on another platform. So that way, mostly we'll be using MS Teams as the tool throughout this session. So let me open. Mm, Okay, so I'll search for that problem, means portal frame method and BTL. Hmm. So these all from NPTEL, what is to be referred, I'll share with you. I have downloaded it in my folder. It is in separate laptop. So I will share all those required things, and portal frame analysis, then beam reaction method, approximate method. Textbook also I will upload. So just go through that. The guideline by CVR Murthy, which we are going to see in the next session, that also I will upload for next session. So this was for the introductory session, and I need all your details, and hope all have paid the fees. I don't know. I have not checked with all who have registered on the Google form. 14 people are there, so I have sent email to all 14 people. I have not checked for the fees, so just ensure that by the time we start with the next class, you have paid all the fees respectively. So EMI option is also there, and if you are taking part as a, means a generator of some uh, data for the course, like making the models or doing some analysis, manual submissions. If you are, means being a course coordinator also, then the reduction in the fee is also there. but that is very limited. One or two people only can get that, mostly to the students of some universities that they are not able to afford. They take part in that way. So anything more from your side? So I need to take your background also. So one by one, can you just explain your background and what you are doing?
Hello, sir.
Yeah,
My name is Mohammad Kazim. I'm pursuing my MTech final year in Geetam University, sir.
from which university?
Geetam, Gandhi Institute of Technology and Management, Vizag.
Why is it? Okay. So welcome to the course.
Thank you.
Yes.
Hello, sir. I'm Srinivas Agrindi, and I'm pursuing my master's in structural engineering at NIT Warangal, Telangana.
Okay. Welcome.
Hi, sir. Currently, I'm working at like Sterling and Wilson Group in Delhi.
Sterling,
Yes.
like this tall build on this mostly high-rise buildings.
No,
Sterling
so
or
it's on only on the solar project, sir. Solar.
okay, okay,
Yes, sir.
okay. So welcome to the online course.
Thank you, sir.
Yeah. So we'll keep the session today up to this point, and I'll upload the documents and please go through them before coming to the session. So you will be more aware that what is going on and you will catch the flow which is required for next 3 months.
Thank you, sir.
So thank you for joining this course and today's session and listening to me. So I'll we will meet for the next session on next Sunday.
Okay, sir. Thank you so much.
Yeah, thank you.